Hi, thank you so much. My name is Natalie, and today I'm going to be presenting about Rust as well as a little bit of infrastructure. The reason is I work as a staff cloud engineer, so my daily job not only focused on building and developing code with Rust or any languages, but also setting up infrastructure and managing Kubernetes is one of the job securities I have so far. So my name is Natalie, I'm a cloud engineer, there's my LinkedIn. I'm also a AWS community builder, as well as I have a user group. If anyone in area like US or California and ever like to present, please reach out and come by and speak in our group. So agenda for today is I will touch a little bit on the Kubernetes ecosystem because I don't know how much everyone here knows about Kubernetes or works on Kubernetes. So to make this talk inclusive for everyone, I will touch a little bit on that. I will explain what Kubernetes operators are, what PVCs are, what these all words are about. But the main focus, it will be how we're going to use Rust to develop certain things for Kubernetes, right? And I will be not doing the live demo because it's a kind of a normal setup. So I will have a demo, but it probably will be like going over the code and just covering those parts. And I will touch a little bit on developing things into production, how do we package them. I'm sure people heard about Docker, so things like that. Let's start. So Kubernetes. Kubernetes is an open source orchestration system, right, where a lot of different things happens and a lot of different type of application can be developed. Kubernetes, what it's good for is once you develop your application, it basically using different types of the system to develop, manage, control, and do a lot of things for us. But it does require some management, it does require some setup and configuration. The applications in Kubernetes are obviously containerized, so that's an important part. The operator I will be talking about is also before, like after we write the code or do anything without it, we have to kind of package it in a container. And yeah, the reason for Kubernetes existence is it helps as a developer to abstract infrastructure in certain levels from the application, right? So, to be honest, when you start with Kubernetes, most of us use Minikube or some other tooling, Key3, things like that. So it feels like it's pretty easy to just run Kubernetes applies and be done. But when you have a lot of clusters and do it in production, it's just impossible to do anything manually. That's why there is certain tools exist in the community, and in some cases, when you try to deploy certain things, they will have specific specs. You might heard about things like resources, like deployments, pods, volumes, PVCs, or maybe you didn't. If you're interested, I would recommend going into kubernetes.io. It has all the details and amazing documentation, has been around for a while, but in some cases, all these standard things are not fitting the use case. And that's mostly happens when you have some proprietary resource that is hard to deploy or manage within Kubernetes system. And operators were designed as a custom resource of that ecosystem to add all things, gadgets we need in order to, let's say, help us to manage our application. I'm giving you an example. Some of us know what backups are. As usually with infrastructure, there is a tool called Valero. It's pretty popular, right? You deploy it. So Valero, in order to have a backup, it needs some volume to store this backup somewhere, right? So volume with Kubernetes, all the resources are usually not stateful. And let's say in some cases, someone could delete the resource because it's not needed, right? In order to, in specific cases, the deleted resource might have other dependent resources. right? So operator like that can help us to do a cleanup or take backup on a backup or do some other things. So everything around management, you can see on the slide, there is certain API, there is certain operator, and there are other system which kind of manages what's going on. And imagine this is completely automated, there is no manual interaction, it's just like living infrastructure. And now, if some of you here work a lot with Kubernetes, they might think, why do we need to use Rust? Because Kubernetes is written in Go, it's pretty popular language, and I would agree with you, but since Rust came in the picture and a lot of people in the community started developing with Rust, it's not super widely adopted, but I feel like it will change. I don't know, don't quote me on that. But I decided to just on this slide to represent a little bit of the idea that both languages are pretty good, but Rust has certain benefits in certain areas like performance, concurrency, or safety, which provide us specifically with the case of Kubernetes operators is a little bit of an advantage, right? So from the performance, yes, Go has concurrency. There is a lot of features that good enough to get you going, but things like, let's say, low-level memory management is not quite there, right? Optimizations in certain areas are not quite there. Similar Go routines, we know, we use, but there is a lot of kind of deep down critical asynchronous tasks that I learned that it's pretty much hard to do with Go, but it was really easy, not really easy, but pretty much reasonable with Rust. And obviously memory safe checks are not there, I would say, which Rust provides out of the box, and this is something I found useful, and yeah, that's my opinion on why we should start using Go with the Kubernetes ecosystem. So operators, as I mentioned, there are different resources. Specifics of the Kubernetes operators, it is a custom resource. So if there are different opinions, and some people would say that you don't need custom resource, but usually if they created by the ecosystem, there is a need, right? What I mean by that is after this talk, it doesn't mean that we all should go and start developing operators, but if we are in a situation where management of the application or some data volume is not handled by it, we should probably think about using it. So it's a process, right? What it does, it uses Kubernetes API to do certain things. For example, watch events, do certain actions, and react on those events. Everything with Kubernetes control loops, what it means is usually the resource have like lifecycle, and someone usually watches for this lifecycle. If you create a resource, it has a living time, and if it was deleted, there is something that will make sure everything was deleted, clean up, and we're ready to continue with the operations. So I want to say that this developing operators almost isolating us as a developers from like learning Kubernetes. Almost, I mean, if we do need to understand the API we are triggering, but that's basically it. So if I will be developing an operator as a person who needs to deploy the app, I would say it's just simplifying a lot for me. And this is where we kind of move to the different slide. So operators with Rust is stateful application for this use case, right? So PVCs are volumes. Volumes are stored data. Usually you don't want it to go away, specifically in production. So this specific operator is responsible for stateful application and make them efficient. Also, operators will help us maintain the app. I call it a second day operation. It's a known term. So maintaining and managing will be provided if you develop your operator correctly. And as I mentioned, usually it's a specific case. So there is a huge possibility of using some third party or specific need, the vendor agnostic thing, that's probably the need for Kubernetes operator right there. So let's begin with, so that was a little bit on the Kubernetes. On the operator, let's talk about how Rust can fit into this picture. So for this example here, I wanted to show usefulness of this presentation, right? And the PVC is something that I didn't find. So there is a operator hub that you can go, and there's certain things already provided, like Grafana operator, some other ones. But PVCs was in a long time a hard task, not just because of the backups. I can give you a different example. We all have secrets in the company, right? We store them in secret manager or vault. When we have things in Kubernetes, most likely it will go on the state application with the state. And it's really hard to manage your PVCs when you do things like upgrading the cluster or anything that requires, even updating the vault, in this case, can affect the PVC or PV, where all your secrets are stored. So you don't want to lose them. That's why you want to design the operator in a way that no matter what happens, there will be certain prediction event of that, and your operator will react on certain action and will do things like delete or manage or create a new one, or let's say if you run out of memory, it can make a request or a claim, like we call it, for a bigger amount of memory and things like that. So for this task, my goal is to just create simple operator. There's PVC and PV involved. Again, PV is the storage that you have in a cluster, and request is something that your application is claiming for that memory. Usually one claim will have a PV. And for this example, my goal is to build a controller that will create something like cleanup action where someone deleted a PV, let's say resource was destroyed, I want my operator to go and clean the resource. And I also will have a monitoring around that, scaling, error sizing. So with Rust, apparently it's not that hard. There are two crates, which is kubectl and Kubernetes OpenAPI. Probably that will cover majority of the tasks. There are certain things that you might need to think, but these two will probably do all the work. And again, it will help. Everything with Kubernetes most of the time is asynchronous, so that's pretty good with Kubernetes. And it does have support for custom resources because, again, custom resources are not so common, although they're becoming more common these days. There's some reason for that. And you can build different watches, you can build different scales, schedulers, whatever you need. And with the Kubernetes OpenAPI, right, it's basically support for all the APIs that Kubernetes have, and then you can easily use that to talk to the cluster. I have done this kind of work many, many years ago using Python, and honestly, it was really, really hard to understand what API to call, how to manage that. So Kubernetes OpenAPI is something I really enjoyed from get-go. So I didn't have that weird learning curve when I had to go and understand the code, what this API is doing, and then write another different code to understand how to manage it. With Rust, this is just given. So Kubernetes has a page how you can build the operator. There's a known pattern. What do you need on your laptop or on your machine or on your server? Rust environment, cluster, Docker, kubectl. Kubectl is a CLI tool we use to talk to the environments in It could be different clusters. Usually you have kube configuration on your machine that has information of how do you authenticate with the cluster. And the other things I use are Tokyo, Seredlog, crates. That is pretty common. I'm sure everyone here familiar with them. So within my controller, within my main function, I would easily connect to the client. Sorry, I would easily create the client and to use the API, initialize the client, obviously with the kube crate. There is basically, there is no need to cover it, how to do it any other way. And it also have error handling. So for line 23, I could just, it will fail not when you cannot access your cluster. It also will tell you, let's say, if kube config is not there. So you can add pretty good error handling for someone for operator to report. And kube has kube logs that easily will be just visible once your operator will run. So controller components that I wanted to show in this example is reconciler, where all my logic for handling the PVC different states are, or could be. Error handler, basically some error handling to describe things that go wrong. And main RC, I also have a config, which I will cover later. It's not on this slide. And again, the state of PVC might change. It will go to the reconcile module, and config would just be described. So the controller part. Within the controller, I needed to handle things like, let's say you started the operator and then something went not as you expected, or the PVC will not bound once you run certain things. So obviously you need some feedback, and it's pretty easy to do it this way. Again, it's asynchronous. So in the end, I guess what I'm getting is that the custom controller, once you, and this is like for the simplicity of this talk, there are certain things you need. Obviously, there will be a logger, and I'm going to jump between these two slides because it's just how things are. So kube runtime, right? Imagine when you, so in your cluster, you deployed your operator to the, let's say, default namespace. You started it. So there is certain reconciliation process where you're trying to understand what's going on in the cluster, what PVs are there, how they attach, what things are happening. And then there's, so I created the object called PVC API that represents what controller will be managing. It will be only covering the specific resource. And if something goes wrong, basically the error will be shown. If you build in advanced operator, usually you want to add things like retries. You want to add things like, let's say when you delete PVC, if you delete the PV, the PV will be there for so long. There's in Kubernetes, there's something called finalizer, which actually making sure that all the resources that are dependent still there until, let's say, certain workload has finished and things like that. So in your reconcile logic, you don't want to just put something simple. You want to have all the retries, you want to give timeouts, you want to have finalizer logic in the reconcile function, module in order to make it behave like everything within Kubernetes. And errors should be very easy to understand, because in some cases, when user, let's say, did something manually, something went wrong, it's really hard because the login system in Kubernetes is really it's busy, right? When you're trying to just run kublogs, it will give you a lot of different things. So you need to create the errors in a way that they just report on things that just happened or went wrong. In some cases, your application might not even going to fail, so there is no way for you to understand, okay, my PVC failed. Like, let's say if you ever use Longhorn, and I apologize if some of you might not. If PVC goes wrong in the Longhorn world, unless you go into UI, you see that something got detached, but there is nothing in the system will ever tell you that something went wrong. So like for systems like this, we want to use this controller and handle state of the PVC when it's detached. And then we want to add the error handling. Sorry, we not necessarily want to add the error handling, but in reconcile, we want to say, hey, if it's detached, try to reattach it because the PVC might still be there, PV might still be there, or if it's completely deleted, create a new one. And the same function you want to see, then your claim submitted the claim and PVC got the claim after it was created, the bond happened, then only then the whole setup will work. So what I'm trying to say that your reconcile should have all the business and small logic, but it shouldn't just fail because it should try to restart and do much more. The context with that controller, obviously, just sharing the state among all the resources within your cluster. So this busy, it's visible. This busy slide will kind of represent the simple main function when you have a logger, you have your client, you have the API, then you have a certain config that I mentioned in the beginning. And again, config can be whatever you want to add and how big you want to build your operator. Then obviously the context and the controller. This is as much as you need to build the basic things for specific cases. To be honest, this is not enough when you start building productional things and cases, and let's say if your production environment has to be up with very, very little downtime with very, very good SLA. So the logic with I talked about reconcile. That's what by this slide I'm trying to describe. When you're thinking about your code, you want to cover as many cases as possible, and it should not be very simple in a way that there are options to recover your resource. If it's deleted, there are options to do a cleanup. So just deleting the resource doesn't mean that it's good, because if your resource, let's say, requesting the memory, and in some cases you have many, many, many resources piled up with the memory requests, by deleting them, that doesn't mean that all memory was freed up. So you need some, as I said, finalizer to go there and make sure everything was cleaned up and deleted. So in your reconcile function, put all this logic. So for my example, which I'm presenting here, reconciliation logic will look something like this. Again, with the Kubernetes, you can have different storage classes. If some of you maybe work with the AWS console, there is resources like GP2, GP3, there is IOPS, right? So all this called storage, and all of these are different classes. Just I'm trying to connect Kubernetes environments to something that you might have seen daily. And then obviously you do the you build the PVC logic. In my example, let's say I want, as I said many times, that I want everything to be deleted. I want to add some good error handling that if something went wrong or if there is an event of the error, I want to try to recover the state of my resource. Error handling is pretty simple. You can make it the way you, config handling is pretty simple. In my case, it's just a storage class. The performance I want to add, I can add like threshold percentage. What it means is, excuse me, if my, I requested the volume size, and then in Kubernetes, the different resources, different application might also have a different requests. At some point, what might happen that all my teammates build the application that requires some memory, but there is not enough memory. My operator can handle this case by just checking if the threshold is reached. If not, or yes, it can add more if there is, again, if there is a room. And that's higher level of infrastructure that's not going to be covered by this talk. Error handling, again, we're all familiar how to, we're trying to handle our errors in the best way possible. Obviously, we cannot cover all the cases in the world. So when you're just developing error policies, as I said, don't just break or fail. Try to see if the error is actionable, because the error you return to the user should be like really bad state where person might need to go and do some manual work. So best practices. Custom resources should be defined very simple in a way that the application already complicated. If you cannot find a basic resource which is up there and you're developing something custom, it has to be very easy to manage it. So think about your teammates or think about automation around it. API convention with Kubernetes are easy, and as I mentioned, there is a crate to do that. Handle the states properly. Basically, everything with the applications in the cluster should be properly stated. Error handling is there. The libraries we discussed. The performance. The performance of this operator is basically falls on the Kubernetes performance. You can, because it's a deployment, right? You can request as many replicas as you want. You can add the resource limits, and I will show it later on a different slide. And obviously, please document your operator. And if you know about security, try to follow the community guidelines. Although my opinion on security with Kubernetes is really not there as I would like it to be, but yeah, that's how it is. So if you want to package this and deploy it to production, what do you need? Again, there's with the infrastructure and Kubernetes, the things we use daily is not like a personal laptop or coding or live code. We actually, as infrastructure people, we playing with the deliverables, how your apps are packaged. So in this case, you can put in Docker. There is no serverless or Lambda for operators, so it's purely just running deployment, which is kind of another application. And Docker build, Docker push, you create, so Docker container, you package it, you create your image, you push it in your ECR, whatever your company is using, is the Docker Hub, Azure, whatever. And then if you use it locally, you can also create the registry with Minikube or with the Docker as well. And then if someone decides to play with it, install in Minikube, Minikube start, will get you there. I have two simple examples of the persistent volume and persistent volume claim, which is a PVC and the claim for it. As you can see, it's the minimum spec you will need. It's all defined in documentation. There is nothing complicated. I deploy it to default namespace, not a good practice, so keep in mind, but for local, be your own boss. So here is, as I mentioned, it's hard for me to do demo and presenting, so here's what I would run Minikube start, I would see the status once it's ready. For demo purposes, I would just apply both resources. In this both examples, when I check for my PV and PVC, you can see there's something already deployed and it's terminating, but the Rustic PVC and PV are there, it was just created. So this is as easy as that. And then, just trying to see, okay, so it's visible. Deploying in a cluster. It's a deployment, so on the first, on the right top corner is a spec for it. Again, deployments are just defined in documentation. The specific thing I have here is, oops, sorry, is the, over here, that's where I define resources for my operator. Here is what a kind of replication, how many of them I want to run in a cluster, things like that. And you can customize it in a way possible. And then once I run Kubernetes apply for this resource, or if you go into production, CI should do it for you, you will get my PVCs, my pods created. And then everything in the cluster needs access. So here is an example of the simple service account that someone who wants to try that in real life will just need. And again, everything will be deployed in the service accounts are all over the cluster, so there is no need to define anything specific. So, key takeaways. The operator we did pretty much easily, can clean up unused PVCs, right? So it was easy to start. It was easy to build. I didn't need a lot of crates or a lot of overkill. The only thing I would recommend to going into asynchronous, like Tokyo, understanding how asynchronous tasks can build using reconcile function is important, and putting your logic there. Again, read on finalizers because there's some, like in my case, I use it for deleting the resources. And data persistence, which my PVC was trying to support, will be achieved in this case in a simple way. In some cases, as I mentioned, it's going to be a hard problem. So here's some links. I don't know if this presentation will be shared after that, but if you want to read on that, it's all here, and I appreciate everyone who came, and yeah, that's all I have. Thank you.
Thank you, Natalie.